Previously, we talked about breaking up the layers of the Earth by composition, what it's made out of. Now we're going to focus on doing the same thing, except it's going to be a little bit more in detail because we're now talking about the structure of the Earth. So when you think about structure, one way I like to think about it is like if you learn about the anatomy and physiology of the body, let's say, you're talking about the structure and the function. What you mean is like, how are things arranged and what do they do? Like, what special features, what jobs do they have? So it's a little bit different for the Earth, but it kind of works the same way. So let's talk about the structure, the features of the first layer. So the way that we're doing it here is like, how do they act, right? So the way that this acts is that they move. So the outermost layer involves things that move, and it's not just one solid rock like some other planets are. Other planets are just the entire thing is one solid piece. Not ours. Ours is broken up into things that we call plates. So it is the rock sphere or the lithosphere. That's where that word comes from. Lithos is, I believe, a Greek word that means rock. It's the outermost layer, of course, but it's not just the crust. It's also the topmost part of the mantle. And they both work very similarly in that they're broken apart. Some people argue about how many plates that there actually are. So we'll talk more about that. But it's roughly, let's say, 13 plates. And they're moving constantly into each other, away from each other, all over the place. Now, this is a very cool video. I'm going to recommend it's how the Earth would look like without the oceans. So just a better view of the lithosphere. And when you get to the edge of the continents, what a lot of people don't notice is that it's not just like this gradual drop down to the next thing. This is what it looks like at the edge. So the water's way up here, and you can obviously wander way out into the beach before you can see this drop down. Like the beaches are way far inland about where you've ever been. But at the very edge of what's called the continental shelf, it starts to slowly decline down. So this is the continental shelf over here, and it slopes down gently until it goes down very, very steep. And that would be the continental rise over here. And then finally, you get this plain where it's like mostly flat at the bottom, but as we'll see later, it gets much more complicated than that in certain places in the ocean floor as well. So underneath you have the lithosphere. Right underneath that lithosphere, you have the asthenosphere. Asthenos is a word that means weak. So it is weak because the plates move around on top of it and it flows like a liquid of sorts. It's not exactly a liquid. It's not exactly a solid. It's this sort of in between, sometimes referred to as a non-Newtonian fluid, kind of like ketchup or blood, where they can flow. They act like a liquid sometimes, but other times they don't. They act just like a solid. So that's exactly what the asthenosphere does. So it is this weak layer. It's the outer layer on which the tectonic plates move. And this zoomed in version really kind of gives you a better view of it. Okay, so if you look over here, this is just a section of the Earth. This orange part up here, over here is the crust. That's a little teeny tiny piece right over there. That's the crust. Okay, and then underneath that, you have the topmost part of the mantle. And then this is the asthenosphere right over here. And then this is the rest of the mantle. So most of the mantle is down here, which is called the mesosphere. Meso means middle. Maybe you've heard of like Mesopotamia, which I believe kind of refers to as like between two rivers. Meso is the middle layer. So we're just going to be 5 layers now that we're breaking up the Earth into. Before we broke them into 3 layers. Now we're in 5 layers. And the meso is the middle layer in between all of those. It is still definitely part of the mantle, breaking that up into being more specific. The asthenosphere, right over here, is also part of the mantle, right? It's the upper part of the mantle right over there, and it flows this way. But over here, the lithosphere is a little bit more tricky because the lithosphere contains the crust, but it also contains the uppermost part of, like I said, the mantle there. So lithosphere contains crust and mantle. Asthenosphere is just the mantle, and mesosphere is also just the mantle. All right, but they all do different things, right? So the mesosphere acts like the majority of the mantle acts, but the asthenosphere works a little bit differently. And you could see right over here, this right over there is a little opening where part of the asthenosphere can rise up to the top and flow onto the surface. So that would be like an underwater volcano right over there, because you can see the water right there. And this is a boundary between 2 distinct different tectonic plates. Here's the tectonic plate over here, one, and then another one over here, and this is that boundary between them. So this plate here, we can see this is oceanic crust. We know it's oceanic crust because there's an ocean above it. And over here, this crust is a lot thicker and it extends above the grounds. So this might be like a mountainous area right over there, but that's continental crust mixed in again with the top of the mantle right over here. And together, this is the lithosphere or the tectonic plates. And you can see that the weight of this ground actually pushes down into this area right over here. And heavy tectonic plates can do that. It kind of presses down on everything underneath it. Now we're going to get further into the Earth. So the next layer down is going to be the outer core. The outer core and the inner core are both very similar to each other. The major difference, I mean, they're both made of the same stuff. We already established that. It's both iron and nickel. But the major difference between them is that the outer core is liquid, whereas the inner core is solid. The inner core is also the densest layer. We know it's the densest because it's at the center, right? Denser things tend to sink down. And almost always, a solid form of material is going to be denser than the liquid form of the material. That's not the case with water. It's one of the few exceptions to that rule because we know that ice cubes float in water, so they're less dense. But for the most part, everything else is denser, and that's the case here. Now, it's under incredible amounts of pressure. We know that because the weight of all of the things above it are pressing down on it at all times. So that is what pressure is. There's slightly less pressure as it gets out over here. We're not entirely sure what is going on here. Like, why is the outer core liquid? Why is this part solid? Some people speculate that over time, there's just this slow transition of liquid to solid, that it's going to solidify over time. And we don't exactly know what the outer core does. It seems that the liquid part here is churning and slowly moving, and perhaps that slow moving is what generates our magnetic field around the Earth. This is not completely substantiated. We don't 100% know that, but it is just a working theory right now. And possibly that when it stops churning, stop moving, our magnetic field will stop generating as well. And that does protect us from our sun and the solar flares that come from our sun. So right now, everything is working kind of the way it should, and that's good. We'll come back to that magnetic field later on in the unit. So we have 5 layers right here of the Earth, all separated by something slightly different. This is a great video that talks about why does it continue to get hot as you get underground, like what is that from? And this is our last definition that you're going to have right over here. So tectonic plates are pieces of the lithosphere that move on top of the asthenosphere. Again, pieces of the lithosphere that they move around on top of the asthenosphere. Some people are going to be asking me, this is tectonic plates, or learn about plate tectonics. What's the difference here? Great question. Plate tectonics is just the name of the overarching theory that talks about all of the stuff. It talks about that there is a theory that the plates are broken up separately into different pieces and that they move. That is the theory of plate tectonics. But what are the names of those individual pieces that are moving? Those are called tectonic plates. So it's a slight difference, but it is important that we know what we're talking about here. When you look at this map, there should be certain things that you notice that jump out to you, right? It says, what are some things that you notice about the picture above? So if this was an interactive slide, I'd be asking you to do that. Well, let's see if you can figure them out. One thing is that there are arrows. The arrows are representing the direction that those plates are moving in. So that's one thing that you should notice. You should notice that some of the plates are only oceanic crust. Like number 1 over here is only oceanic crust, and it seems to be mostly the Pacific Ocean. Hence, that's why it's called the Pacific Plate. You can see some of them are a mixture of both. This one is South America, and it has both South America plus some of the oceanic crust. So that's a South American plate. There's pretty much no plates that are only continental crust. So that's another interesting thing. Some plates are moving into each other, colliding. Some of them are moving away from each other. Like number 5, this plate is moving that way, that plate is moving this way. So there's like an opening right over here. That's interesting. We see that there's some plates that don't have a number here. Like this one doesn't have a number. Neither does that one right over here. That might represent the argument that some scientists have about how many plates there actually are. Some people say there's as many as 20. I've heard as low as like 7. So it just kind of depends. Scientists kind of argue about this, and there's no clear-cut answer. This one over here is the top part is moving this way. The bottom part is moving that way. What could that mean? Perhaps the entire thing is just rotating, or perhaps it's being ripped apart in the middle, and there is a divide forming right in the middle right there. It's known as the Rift Valley. That is one of the theories about why that is happening right there. So there's a lot to kind of take away from looking at this image right over here. But the key thing for you to know is that it's not one solid piece. It's broken up into plates, tectonic plates, and they are all in movement. Now, they are moving at a very slow rate. That's key. They don't move fast. Like right now, we're on a plate and that plate is moving. I don't feel a thing. Do you? Of course not, because the rate at which it moves is something like, I think it might be roughly an inch per year. It's roughly about the speed at which your fingernails grow. So when you look at your fingernails, it doesn't look like they're moving right now. It doesn't look like they're growing. And in fact, you may not know that they were. You just see the evidence of that movement over time, of the growth over time in your fingernails, just like we see the evidence of this over time as well. And that could be from like satellite measurements and other ways that we track that movement.